Right, so this week we're going to focus just on one section, 2.2, and it's what we call unit circle trigonometry. This is going to be the only test that we have through the whole class that you cannot have a reference sheet for. Okay, every other test you can, but this one is the only one that you can't. All right, so unit circle trig, first of all, it's based off of looking at a diagram, and the diagram involves a unit circle. Okay. All that the word unit means is one. So when you have a unit circle, it means it's a circle with a radius of 1. That's the only thing that's special about a unit circle. Okay. What I've done in the circle is I've labeled some angles going around. Okay. So 0 starts on the positive x-axis, 90 is straight up, 180 is to the left, and 270 is on the negative y-axis, going down. Any question on that diagram? How I labeled those different angles going around it? And I mean, you could label more. I mean, you could put 30, 45, and label as much as you need, but that's all we really need for right now. Okay, so the whole goal of unit circle trig is to figure out a coordinate. Right. So what I'll do is you'll have a point right here. Okay. Maybe that point represents a 30-degree angle. Okay. It doesn't matter what it represents, but it would represent an angle. And if you drew it, there would be your angle right there. And the goal is to figure out the coordinates of that point. That's what you have to figure out with unit circle trig. So you can draw an angle, that's fine. Then when you draw the terminal side, it comes out from the center, and it's going to hit the edge of the circle somewhere. You have to figure out where it hits. Right? And then once you know where it hits, you're going to have an x value for where it hits and a y value, and then you can do unit circle trig. So that's the goal. Some angles are easy to find. We're going to work with angles that are multiples of 30 and 45. Those ones are easy. When you get angles that aren't multiples of 30 and 45, you have to use a calculator. All right. So unit circle trig can only be used to do, we'll call them nice angles. Okay? And by nice, I mean like 30, 60, 90, 120, or 45, 135, 225. Those are multiples of 45. And I think I wrote that all out, but if you understand what I just said, you don't need to write this. But every angle that you draw in red inside that circle can be represented as a coordinate. And that's basically what I just explained. Now, there's two directions you can move when you're moving in a circular motion. What are the two different ways you can move when you move on a circle? Right, clockwise and counterclockwise. Depending which way you move is going to dictate whether or not you're dealing with a positive angle or a negative angle. So on any circle, not just the unit circle, but if you move counterclockwise, you're dealing with a positive angle. All right, so Aiden, if counterclockwise is a positive angle, what do you think clockwise would be?
Negative.
Yeah, it would be negative. Okay, so remember, counterclockwise goes that way. Okay, the opposite way that a clock would go. Clockwise, that way. Now, if we had a choice and we could choose whether or not we work with negative or positive angles, which ones do you think we'd pick? Positive. Yeah, positive is generally easier. Arithmetic is easier. You don't have to deal with negatives. So if we can, we're going to try to think of things as positive angles. Okay, so let's take a look at that on a program where you can actually draw out the angle, and you can see if you go counterclockwise, it's positive, and clockwise is negative. So as I start moving clockwise, you can see that it's giving me a positive angle. Now it's giving me a number up here in degrees. Does anyone remember what the number down below is? It's radians, all right? And then for certain ones, remember pi is involved a lot with radians, so we'll come back to that today. All right. And then if you go more than one revolution, now you're getting angles that are more than 360. For the purpose of unit circle trig, 90 degrees, okay, look at, okay, for the purpose of unit circle trig, look at where that red circle is. Okay, notice exactly where it is. It's right at the top. If I go like this, and I bring the angle to 450, how does that red circle compare now to where it was before? Yeah. You're looking at me like, well, something. It's just 360 more. So if you took a picture of where that red circle was before and where it is now, how would they compare?
The same.
Exactly the same thing, right? There's no difference. So when we do trig, if you want to work with the number 450 or you want to work with 90, it's exactly the same thing. Okay, those two numbers are the same when you're doing trig. Which one do you think I'd pick if I had a choice? 90, it's smaller. So we're going to learn when we have angles that are too big, you know, like a big angle like that, 900 degrees, there's a smaller version of 900 degrees you can work with that's easier, right? And we have to find that, and it has something to do with 360 and arithmetic, right? So we'll come back to that. Right, same thing if you have negative angles, right? If I put the circle right at the bottom, I went clockwise. That's a negative 90 degree angle. Well, if I had a choice, I'd rather work with the positive version, which is 270. Right? So we can change angles that are too big and make them smaller. We can take angles that are negative and make them positive, make them bigger. All right? And I'll show you how to do that. But any questions on the two directions that you can move? So, if you've got an angle that's too big, right? So, Al, you noticed that it was just 360 degrees different. That's all you have to do to make an angle smaller, is just subtract 360. But you don't want to subtract 360 too much, because if you subtract it too many times, what would happen to your angle? Then it would turn negative. So, you want to keep subtracting 360. Till you get an answer between 0 and 360. For most people, it's pretty straightforward. Like if I said to you, 112 degrees, you could kind of picture what that would look like. Right? Not a little more than a 90. But if I said 3,750 degrees, it's kind of hard to figure out what that would look like because it's so big. You've gone around so many times, it's confusing. So I would just subtract 360. To make it smaller. So if you can subtract 360 to make an angle smaller, what do you think you have to do to make an angle bigger? Add 360. Adding and subtracting 360 is all that you can do. Because 360 brings you around one full circle and brings you right back to where you started. If you add or subtract any number other than 360, you're going to get it wrong. You won't go back to where you started. Okay, so add 360 as many times as you need to till you finally get an answer between 0 and 360. And that's going to be the easiest version of the angle to work with. Okay, so let's say somebody asked me to draw the angle or figure out the coordinate for negative 1200 degrees. Off the top of my head, I'm not sure what negative 1200 is. I can do it on here and figure it out. So negative 1200 is right there. Okay. But if I would have just taken the calculator and said, okay, since I don't want to deal with a negative angle, I'm going to add 360. I'm going to do it again, and one more time. So negative 1200 If I put it at 240, okay, watch where the circle is right now, and let me put it at 240. Maybe. 240. It's in exactly, can't quite get it exactly. It's in exactly the same spot as it was before. And that's all we care about. Where is this spot? What's the coordinate? Okay. We haven't talked about how to find the coordinate yet, but that's what we'll do next. Right. Let's see if we can figure out the coordinates for these four angles. 0, 90, 180, and 270. Okay. For now, I don't really need any of that stuff. But you can keep it. You don't have to erase it. 0, 90, 180, and 270. All those angles are special. They all have something in common. You can tell me what they all have in common? Yeah?
They're all on an axis.
They're all on an axis. And anytime you have a point on an axis, it means that one of your coordinates is going to have the number what in it?
0.
0. Yep. So all of these points have a 0. Now, all you've done for every one of these points is started at the center and moved one unit, either up, down, left, or right. So let's start with 0. To get to 0, you move one unit, but which way do you move? Up, down, left, or right?
Right.
You move right, starting from, here's your origin right here. So what would be the coordinate if you start at the origin and you move one unit to the right? Well, what?
1, 0.
Yeah, 1, 0. So that's the coordinate for 0 degrees, and that's always the coordinate. That never changes. Let's do 90. So for 90, that's where you start at the origin and you move one unit up. Anyone think they know what the coordinate for 90 degrees would be? Yeah, Devin?
0, 1.
0, 1. Yep. And that's always the coordinate for 90 degrees, 0, 1. How about, Connor, how about 180?
-1, 0.
0. Yep. So there's your coordinate for 180 and 270. How about Jasmine? What would be the coordinate for 270?
0, -1.
0, -1. Now, they could be a little tricky to remember because they all have 1s and 0s in them, or negative ones. But if you draw the diagram and just look at it, as long as you know up is positive, down is negative, left is negative, right is positive, you can just look at it and kind of figure it out. So you don't even really have to memorize it. Okay. Any questions on how we got those four coordinates? Okay, so those are the easiest four to get. Okay, they're the nicest coordinates we'll probably have all week. All right, so now what I'm going to give you is the definitions of the 6 trig functions. And you might have done this as like opposite over hypotenuse, adjacent over hypotenuse. Has anybody done those before? Yeah, that's right triangle trigonometry. We're going to look at that next week. Once we learn right triangle trig, I can compare it to what I'm showing you right now and show you it's exactly the same thing. Okay? I'm just not going to use the words opposite, adjacent, and hypotenuse. I'm going to define everything here as part of a coordinate. So that means all of these formulas are going to have an x, a y, or both of them. Okay, so all these definitions are based on figuring out a coordinate. If you can't get the coordinate, you can't do unit circle trig. It doesn't work. Okay, so first 3 trig functions, because this is the first time we've seen them, I've written them out. I'm going to show you their abbreviations, but we've got sine, which we abbreviate SIN. All trig functions are abbreviated with 3 letters. For most of them, it's just the first syllable of the name. So, sine, I'm sorry, not the first syllable, just the first three letters. Cosine, and tangent. That one is the first syllable, I guess. So if you look at like a scientific calculator or a graphic calculator, those are the abbreviations you'll see. SIN, COSTAN. Okay, so let's start with sine. Now, you're always going to be taking the sine of an angle. So just to explain what that would look like if you actually filled in a number, it could look like this. That's not sine times 90. Just like this, you don't read this as the square root times 90. You just say the word of. Square root of 90. Square root of 90. Okay. Same thing here. Sine of 90. Right? This is kind of what you're plugging into the square root function. Well, this is what you're plugging into the sine function. Right? So anytime you have a function, you have to plug a number into it. And that's what that is. So, to figure out the sine, the first step is to find the coordinate. And the answer for the sine is just the y value of the coordinate. So there's really no arithmetic or any calculation you have to do. You just find the coordinate, and if they want to know the sine, you tell them the y value. If they want to know the cosine, you give them the x value. And if they want the tangent, this is one where you have to use both. You find your coordinate, and you take the y value and divide by the x value. Right. Now, there's three other trig functions. Does anybody know the names of the other three, or even one of the three? How about if I give you an abbreviation? That's an abbreviation for the first one. Does anyone know what that one stands for? Or this one? Or that one? How about, based on the ones I already gave you, anyone think they might know one of them? Yep.
Cosine, tangent, or is that like not a thing?
Which one are you looking at?
The bottom one.
The bottom one? So it does have something to do with tangent. You just put the word co in front of it. So it's just cotangent. That's it, cotangent. Yep. And these two are also the same thing, except one has co in front of it, one doesn't. One of them is secant, the other one is cosecant. So we can't use COS for secant, cosecant. I said usually you just use the first three letters. Why can't you use the first three letters to abbreviate cosecant? See, because what? Yeah, we've already used COS somewhere else. For the other five, it's just the first three letters. SEC, COT. But for cosecant, they just use the first letter of each syllable. Cosecant. And now, there's a reason why I wrote them in 2 columns and 3 rows. Because there's a relationship between the ones that are across from each other. And I'm going to just show you the first one and see if you can tell me what you think the relationship is. Now, the first one here, y, it's not a fraction. But if you wanted to make something a fraction, you could always put it over what number? 1. Okay, I'm going to erase that because we don't normally do that, but I mean, you could if you really wanted to. So what does it look like the connection is between the sine and the cosecant? Well, we gotta be careful. Opposite would usually mean like one's positive, one's negative. So there's another word, I think I know what you're getting at, but there's just a different word we have to use. Yep? They're the reciprocal of each other. Or you could say, if you wanted to be simple, just say they're flipped. So the sine is y, the cosecant is 1 over y. So based on that, what do you think the secant would be? The reciprocal of the cosine, which would be 1 over x. And the reciprocal of tangent would be x over y. So those are the 6 basic trig functions. The only 3 that you're going to see buttons for on the calculator are the 3 on the left. The 3 on the right, they don't have buttons for them. You have to use the button on the left to figure it out. So like if somebody asked me what's the cosecant of something, what I would do is I would find the sine of it first and then take my answer and flip it. And that would give me the cosecant. So everything here is based off knowing a coordinate. Okay, the x and the y, remember that's going to come from a coordinate. Once you draw your angle, that's what you need to know right there. That's the x and y value you're looking for. So the angles that we looked at earlier, I asked somebody what's special about them, and someone said they're all on the axes. Well, the axes are what separate your plane into quadrants. So that's why these angles are called quadrantal angles. 0, 90, 180, 270. So if you see that word come up in the homework or you see it on the test, now you know what they mean by quadrantal angles. It means it's one of those 4. All right, so how do we actually do unit circle trig? Okay, there's 2 steps. The first step is to find the coordinate. Okay, if you wanted to summarize all that, you could really just say you're finding the coordinate. Okay, the way I wrote it, it says locate the point on the unit circle that corresponds to your angle. So you got your unit circle, draw your angle, and then you're looking for the point where the terminal side of the angle hits the edge of the circle. That's what you're looking for. Now, sometimes you're given the point. If you're given the point, then step 1's already done for you. I'm just going to skip to the next page, but I'll come right back, and I just want to show you what it looks like when step 1 is already done for you. Example 1. It says let P be a point on the unit circle. They're giving you the coordinate. Here's an x value, here's a y value. So you don't have to find them yourself. Right now, there's only 4 coordinates that you know how to find yourself. You know how to do 0, 90, 180, and 270. I showed you those 4 coordinates because they all have a 0 and a 1, or a negative 1. If we're going to deal with an angle that's not a 0, 90, 180, or 270 for today, I'm going to have to give you the coordinate because you don't know how to find any of the other ones yet. Okay, tomorrow we'll look a little bit how to find some of the other ones. All right. Now, once you have the coordinate, you plug it into the formula. Which formula? Any one of the 6 that they ask for. If they ask for the sine, plug it into that one. If they want to know the cotangent, plug it into that one. So you find whatever trig function they want. What we're going to do is we'll practice doing all 6. Okay, in each problem we'll find all 6 of them because we need to kind of practice doing them all because you don't know which ones are going to come up on the test. Right. So step 1, find the coordinate. Step 2, plug it into the formulas. Okay. As far as the explanation, that's it. So now for the rest of the time, we'll do some examples. And you'll probably have maybe 20 or 25 minutes, depending, to start the homework. Everyone have the 2 steps?
No.
All right, so everything that's written in example 1, that's all directions that you would have in the problem on the test. Let P, let's use P because it stands for point. Let P be the coordinate -1/2, comma, √3/2. Now, first thing, when you look at the coordinate I just circled, does that look like the coordinate for 0, 90, 180, or 270? No. Why not? Why doesn't it look, what's different about it? Yeah, there's a fraction in there. There's also a square root. The coordinates for 0, 90, 180, and 270 were all zeros and ones and negative ones. So that means this coordinate right here represents an angle other than one of the quadrantal ones. What angle does it represent? It doesn't matter. You don't need to know that. Because the question, I didn't say what angle does this represent. I just want to know what is the sine of the angle? What is the cosine of the angle? So it's like I want to know a bunch of things about the angle, but I don't care what the angle is itself. It's kind of like if I didn't know someone's name and I wanted to describe a bunch of things about them, I can do that. Like I could look at any person in the school and describe what color shirt they're wearing, their eye color, their hair color, roughly how tall they are. I don't need to know the person's name to do any of that stuff. It's kind of what you're doing here. You're never going to know the size of this angle. You're just going to describe some things about it. That's all you're doing. Okay, so let's start with the sine. So, Ellie, what's my formula for sine?
Isn't it 1 over y?
That's your cosecant.
Oh, so y over 1?
Y over 1. Yep, just y.
Just y.
So, here's x, here's y. So all we have to do to write down the sine of this mystery angle, which we don't know, is to write down the y value of that coordinate. So that is the sine of our mystery angle. And this symbol, I think we talked about it last week, that's the Greek letter theta, T-H-E-T-A. It's just a letter that we use when we don't know something in trig. Kind of like in algebra, you use x a lot or y. Well, we use that Greek letter a lot in trig. Okay, let's look at the cosine. So Ben, what was the formula for cosine? X, and what's my x here?
-1/2.
Yep, -1/2. If you get the coordinate right, those are the easiest 2 to do because there's no arithmetic at all. The other ones involve either flipping or doing a fraction. Okay, let's look at tangent. How about, Libby, what's my formula for tangent?
Y over x.
It's y over x. Well, I've got y right here. I've got x right there. Y over x. So let's write that down. There's y over x. Now, that's really messy. We've got fractions over fractions. We don't want to leave it that way. When you have a fraction divided by a fraction, how do you do it? You flip which one? You flip, yep, flip the -1/2. So that's the first step. You got to flip the bottom, and then what do you do with it? And then you multiply. So if you were to do that, you leave the top the same. You flip the bottom one, and you multiply. When you flip, it doesn't matter where you put the negative. You can put a negative in the top of the fraction, the bottom of the fraction, same thing. what happens when you multiply those two fractions? Before you even start, there's something you could cancel out first, yeah?
The 2's cancel out.
Right. So whenever I see a fraction over a fraction, if they have the same denominator, I cancel them right there. If you don't want to do it that way, that's fine. Flip and multiply, and then cancel them. You're going to end up with the same thing. Square root of 3 divided by -1. Square root of 3 with a negative, the answer is the negative square root of 3. That's it. Okay. So once we have the 3 on the left, the 3 on the right are easy because of the connection. What do you do with the 1 on the left to get the 1 on the right? Just flip it. Yep. So let's do the secant. Only because that one's going to be the easiest. What do you get when you flip -1/2? Yep. -2. Maddie, how about when you flip the square root of 3 over 2?
Is it just 2 over? Yeah, 2 over the square root.
Okay, so we get 2 over the square root of 3 when we flip it. And now, this came up last week. Anyone remember what I said here? There's something there we gotta be careful with, yeah?
You can have a square root on the bottom.
Right, we don't want to leave the square root in the bottom. So do you remember how to fix that?
You multiply the top and bottom by the square root.
Right. You can multiply a fraction by anything you want, as long as you do the same thing in the top and the bottom. Right? If you don't do the same thing in the top and the bottom, you just messed up your fraction. Right? But we're doing the same thing in the top and the bottom. So in the top, we get 2 square root of 3. And in the bottom, square root of 3 times the square root of 3 is the square root of 9. Or just 3. Okay, so we've got 5 out of 6. We got one more to do, which is the cotangent. Now, the relationship is you flip the one on the left, but the one on the left isn't even a fraction right now. So how can I make it a fraction? You got a guess, Peter? Well, we want to just make this number a fraction first. You can always... Yeah, just put it over 1. I'm just going to kind of put that as like a dotted 1, like it's invisible. But you could do that. Put it over 1. Now you've got a fraction you can flip. So Jake, if you flip this fraction, what would you get?
1 over the square root of -3.
1 over the what?
Oh, the square root of negative, or the square root of 3, negative square root of 3.
Yes. Yep.
Yeah.
Okay, and now we've got the same issue we had when we did the cosecant. We're going to have to fix that square root. So Aiden, what do I multiply by to fix it?
3. -3.
Not -3.
Just 3.
It's not negative or positive 3. So you got to multiply by something different.
Just the square root of 3?
The square root of 3, yeah. So square root of 3 over square root of 3. Same thing we did up when we did the cosecant.
Wait, those don't have to be negative?
No, they don't have to be negative. Because it's okay to leave a negative in the bottom of a fraction. That's not a problem.
Okay.
Just leaving a square root is a problem. And Kayla, when I multiply out, what do I get in the top?
The square root of 3.
Yep. And in the bottom?
The square root of 9.
The square root of 9, or negative square root of 9, which is?
-3.
-3. Now, you can keep the negative in the bottom, or you can put it in the top. Most of the time, you're going to see a negative in the top. Again, if you leave it in the bottom, it's not wrong. Okay. Any questions on that? So this kind of problem, this would be 6 separate questions on a test. 1, 2, 3, 4, 5, 6. Okay, you're not going to have to do all 6 in the same question like we did here. They would all be separate. Okay, let's look at this one. Okay, so find the 6 trig functions of root 2 over 2, comma, root 2 over 2. Okay. Connor, is that the coordinate for one of the quadrantal angles?
Oh. I'm not sure.
Not sure. Anyone can help him out? Is that the coordinate for one of the quadrantal angles? No, why not? Right, if it's a quadrantal angle, it's a 0, it has a 0 in it somewhere. So that again is not the coordinate for a quadrantal angle. Does anyone know what that is the coordinate for? It's not necessary to know that to do the problem, but it's the x and the y value are exactly the same. So think about if you drew an angle and you went over and up the same amount. Anyone have a guess what that angle would be? Yep. How much? Well, a right angle would be 90.
Oh, it's 180.
Well, 180, that's negative 1, 0. So it's not a quadrantal angle. It is. That's the coordinate for a 45-degree angle. Because you've got a circle, and you've gone over, well, I didn't draw my circle very well, but you've gone over and up the same amount. So if you go over a certain amount and then up the same amount, you're at a 45-degree angle. Tomorrow we'll see how to get that coordinate. So you don't need to know that that's a 45-degree angle right now, but it is. Okay, so let's go through our trig functions. Aaron, what would be my sine value? Square root of 2 over 2. Now, since they're the same here, even if you mix them up, you'd still get it right. But can you tell me which one, just so we know? It's the one to the right, which is the y. Yes. Most of the time, if you mix up the x and the y, you get it wrong. Here, you'd be okay. So that's the sine. How about Caitlin? What's my cosine? Yep, and that's coming from which one?
X.
That's from the x. And now the tangent, we want to divide the y by the x. Yeah.
It's 1.
It's 1. They're the same thing. Exactly the same thing. So since the tangent came out to 1, that's going to make the cotangent pretty quick to find. That's the easiest one to do, so let's get that one out of the way. What's the cotangent? 1. Because all we do is flip 1, and when you flip 1, you get 1. If you're not sure why it stays the same, but you can always make it a fraction. Think of it as 1 over 1. Still 1 over 1 when you flip it. Okay. Let's do the cosecant. How about Peter? What do we do again? To get the one on the right, we just take the one on the left and one word. What do you do anytime you have one of these to get the one over here? Just take this and Ellie, can you help him out? Not divide. Yep. Flip. That's it. You just take the one on the left and you flip it, and then you get the one on the right. All right. Now, when you do that, sometimes you might have to fractions over fractions and stuff like that. But the simplest way to think about it is just to take this and flip it, which I think is kind of what you said with divide.
Yeah.
If you think of it like this, yes, that is correct. But in my head, I just think flip it, and then I don't have to deal with fractions over fractions. All right, so flip it. 2 over the square root of 2. And Ben, is that okay for the final answer?
No.
No? What's wrong?
You can't have a square root on the bottom.
Yep. And can you just tell me how we fix it?
You multiply
multiply by square root of 2 over 2.
Square root of 2 over,
1 or 2.
not 2, square root of 2. Anytime you multiply a fraction, it's got to be the same thing in the top and the bottom. Otherwise, you just change the fraction. Okay? That doesn't change it. Doesn't change its value. It just writes it in a nicer way. Right. So how about, Maddie, what would I get for final answer there?
I'm gonna just be. Can that right fraction be 1 and just multiply by 1 since it's a bit?
Well, it is 1, but we don't want to make it 1 because if we do that, now we're right back to where we started with.
Okay, so would it be the 2 times the square root of 2?
Yep. So 2 times the square root of 2 over 2. Yep. And then the 2's cancel out. So anytime you flip square root of 2 over 2, it just turns into square root of 2. So now that we know that, what's the secant? Square root of 2. Because we'd be flipping the same thing we just already flipped before. Okay, so again, 6 different answers. That would be 6 separate questions on the test. Any questions on that one? All right, so let's try one more of those. And this time I'm going to have you guys take a shot at it yourself. Okay, so again, they're still giving you the coordinate. This is the last one where they're going to do that. The next one, you're going to have to find the coordinate yourself. Okay, so they've given you the coordinate. Try to find all 6 trig functions. All right, so let's start to take a look at it. So first 2, sine and cosine, are always the easiest because you just have to copy down part of the coordinate. Just make sure you copy the right part. All right, so Aiden, what did you get for the sine?
Negative 1 over 3.
Nope. Negative 1/3. Perfect. How about Kayla, the cosine?
2 square root of 2.
Yes. And now the tangent, you're just going to be dividing the 2 that you just wrote down. When I divide them, I just kind of almost pretend like I'm putting an imaginary fraction bar right there in my head, and I look at it, and I already see something that's going to cancel. What cancels when you divide y by x?
3.
The 3's. So all I'm left with is a negative 1 divided by 2 square roots of 2. So the 3's are gone, and I end up with a square root of 2 in the bottom. So what do you multiply by to fix just the square root of 2 problem? Just the square root of 2. That's going to give you negative square root of 2 in the top. Now, in the bottom, you've got 2 times the square root of 2 times the square root of 2. Let's do this first. What's the square root of 2 times the square root of 2? 2 times another 2? 4. That's the answer. Negative square root 2 over 4. So I don't know if you saw what just happened, but when I put my negative, it almost looked like it was part of the line. It was even a little closer than that. So to be clear, it's probably good to put the negative in the top so it doesn't look like it's part of the fraction bar. All right. Connor, now that I've got the 3 on the left, what do I do with each one of them to get the ones on the right?
You flip them.
Flip them, that's it. So the first one, that one's pretty easy. Negative 1 over 3, when you flip it, negative 3 over 1. Secant, you're going to get 3 over 2 root 2. It's kind of like what you just had over here. You had negative 1 over 2 root 2. You're going to fix it the same way. Anybody tell me what they got when they fixed that? Yeah.
3 square root of 2
3 square root of 2 over.
4.
Yep. Now, if the 3 and the 4 reduced, like let's say it was 3 square root of 2 over 6, then you could reduce that. But 3 and 4 can't reduce. And then the last one, we're going to flip it. Did it work?
Do I walk back?
Yeah. Just type your ID. Yeah, that's it. So negative 4 over the square root of 2. And you're going to fix that exactly the same way we fixed them all. Multiply by the square root of 2. On the test, I'm not really going to look that you showed me that step there. As long if you get the final answer, you just type your ID. Yep, if you just type the final answer, you're good. So negative 4 square root of 2 over 2. Now, this is the case where I told you it could reduce. 2 goes into 4 how many times? 2.
So what do I have to do?
2 goes into 2 once. 2 goes into 4 2. So the final answer is negative 2 square root of 2. So with these problems, I think the most annoying thing is just you got to fix the square roots and you got to reduce. The actual like formula from the trig part, it's a pretty easy formula. You just flip something. All right. So let's finish up with looking at a couple of these types. What's different about this problem? It's not the same as the first 3 we did. Say yeah. Okay. So what if, so they gave you the what here? They gave you the angle. That's not what you want to have. You can use that to get what you need, but that's not what you want to have right now. What do you need to have instead of that angle? You've got to get the coordinate. So that's the first step. You have to find the coordinate for 90 degrees. Now, if you don't remember where it is, draw your circle and just think of where the angles are labeled, right? Starting on the positive x-axis. Where's 90 on the circle? Oh, 8. Yep, it's at the top. And if I pick the coordinate that's at the top, William, what's the coordinate for the point that's at the top?
What's the 1 or 0? The y coordinate, or it's 0 and 1.
0, 1. Yep. Now this problem is just like the last 2, except it's going to be even easier because there's no square roots in the coordinate. Okay, so let's go through our values. Jasmine, what's my sine? Yep, sine is 1. Ben, my cosine?
0.
0. And Libby, what's the formula again for tangent?
Y over x.
Y over x. So it's 1 over 0. Now, what is 1 divided by 0? Can't do that. So you write undefined. So tangent of 90 is undefined. All right, Caitlin, how about the cosecant? 1? Now, to get the secant, we need to flip the cosine. Well, it's not a fraction right now, but I could make it a fraction. And Peter, how do I make it a fraction? Yep, you put it over 1. So to get the secant, you're going to flip 0 over 1. What is 0 over 1 when you flip it? Undefined. It's what we just had for tangent. It's 1 over 0, or undefined. So when you flip 0, you get undefined. What about when you flip undefined? You get 0. And And those are your 6 trig functions. Yeah, question?
No, nothing.
That's it. So usually with a quadrantal angle, the arithmetic is faster. Okay, this one, they're only asking for 3 of them. Sine, cosine, tangent. What's a little different about this one? What does that mean? If they've given me something with pi, what have they given me?
Radian.
They've given me something in radians. It's still an angle, but it's in radians. So what I would do is first change it to degrees. Okay? That's probably going to make it easier to figure out the coordinate. Does anyone remember what you multiply by to change radians to degrees?
Like 180 over pi.
Yep, it's 180 over pi. Perfect. Pi's cancel. 3 times 180, well, it's like just doing 3 times 18, and then add a 0. What's 18 times 3? That's 18 times 4.
56. I'm still wrong. 54.
It's all right, you're trying. What is it? 54, yes. All right, so now at least I have an angle that's in degrees, but I still don't like that angle. What don't you think I like about it? Yep.
It's too big.
It's too big. So we talked about a way we can make it smaller. How can we make that smaller? And I bet once we do, you'll recognize what the coordinate is. Subtract 360. That's 180 degrees. So now, think of where 180 degrees is. It's right there. So what's the coordinate for 180? Negative 1, 0. Now you can do the problem using the coordinate. Okay. So my sine, how about Maddie, what's the sine here?
0.
Yep. So sine is 0. Dan, what about my cosine? Yep. Negative 1. And now the tangent, you're dividing the y by the x value. 0 divided by negative 1. So what does that come out to? That comes out to 0. Yep. So just make sure you don't mess that part up on the test when you divide by 0. Okay. Sometimes a simple way I show people to remember it is if you have a number divided by 0, it spells no. So you can't do a number divided by 0. If you have 0 divided by a number, it spells on. You're on track. Keep going. You're doing it. I don't know. Just remember, number divided by 0 spells no. Can't do it. Okay. So, any questions on those? All right. So homework tonight is going to be in the book. Tomorrow night is going to be a worksheet. Okay, so if you're going to be out tomorrow, I'll try to put the worksheet at the end of the video. And you could just copy the problems down. I think it's 10 questions on the worksheet. Tonight is 11 to 27 odd and 22. Okay, so remember tomorrow with the MCAS, we only have half a class tomorrow because they're not having periods 3 and 4. So we'll do as much as we can, and if we need to catch up on Thursday with the review day, that's fine.